Hello everyone, welcome back. I hope you're doing great. So let's have few more questions today. In this set, you will find questions from research methodology and statistics section. And 10 out of 10 questions are taken from previous NTA UGC NET examination. So let's begin. Our first question is, which of the following cause non-sampling error? Now we have two types of errors, sampling and non-sampling errors. Sampling errors are caused when there's population, which is the sample you have selected from the population is not representative of the entire population. That is what a sampling error is. If there's no replication in the sample about the characteristics of the population. And non-sampling errors are of two types. There can be random errors for which you cannot have any accountability, and the systematic error. Now in systematic errors, you will find errors due to in the recording process when you are recording the data, recording the responses. So there can be errors in the instrument you have designed for the data collection, that is the questionnaire. If there's errors with the questionnaires or the person who is collecting the data, investigator, if he has some biases or he is having poor practices in collecting the data, so these can be errors in the recording process. Then comes the processing orders errors. When you are processing the data, if there's errors in that process, then comes the non-response errors. Now non-response errors are the errors when you have selected a right sample, but some of the participants or any participant is not willing to reply, is not willing to give the responses, is not willing to participate. Then in that case you have non-response error, which is one of the non-sampling error. Same is the coverage error, that if somebody you are investigating for um, twice, if you are collecting the information from the same person twice, so that can be a type of coverage error. So there can be various errors in non-sampling errors under systematic errors, right? So if we look into the options, there's vague and imperfect questionnaire. So it is an error with respect to the questionnaires you have designed, that is the instrument you're using for the collection of data. So this is a non-sampling error. Then comes the bias in the estimation method. Now estimation is that you are estimating that any characteristics of the population is representative by the sample. Say mean of the sample is 25, that means that this 25 is the mean of the population as well. But if there's biases, if there's error in the estimation method, in the estimation process, then that is a sampling error, because there's a bias in estimation. So this bias will cause no replication, no representation of the population in the sample. So that's why it's a sampling error. Same goes with the variability of the population. If population is variable so as that it is difficult to have a sample representative of that population, of that whole population, because its variability is such that it is difficult to have a representative sample, then it is also a sampling error, because whatever the sample you will choose, select, that will not represent the entire population. Coming to the option number D, which is personal bias of the investigator, as we earlier talked about, that recording error can be because of instrument that you selected and the investigator who is collecting the data. If he has the personal biases, there's personal bias of the investigator when he's collecting the data, when he's recording the responses, then it will be a non-sampling error. So answer option A and option D. Both the errors are non-sampling errors. I hope you understand. Moving on to the next question, which of the following are the parametric test? We have two types of tests, parametric and non-parametric. Now in parametric test, the data should be distributed normally. So there should be normal distribution. This is the first assumption of parametric test, that the data should be normally distributed. That simply means that it should be a bell-shaped graph, that is mean median and mode should have equal values. So that is a normal distribution is about, when mean, median, mode are equal, right? So if you have a data set which is normally distributed, for which mean, median and mode values are same, then you can go for parametric test. These are t-test, z-test. T-test you can conduct when data size is less than 30. When it is more than 30, then you will have to go for the z-test. So these are parametric test, option number A and option number B. Chi-square test and runs test, these are types of non-parametric test. For a non-parametric test, there's no such presumption that you need to have a normally distributed data. So you can conduct any non-parametric test when you are going for any data set which is not normally distributed. So such as one of them is chi-square test and runs test. Runs test which basically determines the variability of a sample. So this was second question number second. Moving on to the third one, in factor analysis, which of the following tests this hypothesis whether the population correlation matrix is an identity matrix or not? So Bartlett test is the test which is conducted to find the identity matrix, and if the Bartlett test value comes less than 0.05, that means you can go for a factor analysis. Factor analysis is basically when there's so many variables, there's large number of variables and you want to reduce the data. So to reduce the data, and these number of variables can be reduced to few factors, factor 1, factor 2, factor 3. So that is what basically a factor analysis is. A lot number of variables can be reduced to few factors. So this is a factor analysis is about, and for a factor analysis you need to have Bartlett's test of sphericity's value less than 0.05, right? It just checks for the identity matrix, if the population correlation matrix is an identity matrix or not, right? So we also need to have a KMO value while conducting factor analysis. The KMO value should be sh when it's basically how your sample is adequate, right? So it tests for the sample's adequacy, individual variables adequacy it check for. So its value should be above 0.5. If the value of KMO is above 0.5 and Bartlett's test value is less than 0.05, that means you can go for a factor analysis. So KMO tests for the adequacy of the sample, and Bartlett's test it checks for the correlation matrix is an identity matrix or not, right? So it just check for the identity matrix of the data, right, of the population, that correlation matrix is an identity matrix or not. Identity matrix basically means your variables are not unrelated, right, and not ideal for factor analysis, because in factor analysis you are basically reducing the n number of variables into few factors based on some covariance. There's some covariance among them, on the basis of which you are finding few factors from data set. So identity correlation matrix simply means that your variables are unrelated. If they are unrelated, there cannot be any covariances, so not ideal for any factor analysis. So that's why we check for Bartlett's test of sphericity. So answer for this question is option number 1, which checks for the correlation matrix is identity matrix or not for a factor analysis in hypothesis testing. Moving on to the fourth question, under which of the following conditions binomial distribution cannot be used? So binomial distribution is simply the one takes which two results, success or failure, right? Only two results. So it is similar to the that theorem which basically it's binomial distribution. We have multiple in, right, multiple independent variables, right? In a Bartlett test. However, if you in a Bernoulli's trials, we also use Bernoulli's trials. For that also you have two results, but in that Bernoulli's trials you do not have multiple variables, right? You do not check for multiple trials. You in Bernoulli's trial you only have one trial, right? So looking at the option, there's and the number of trials is finite and fixed. Okay, so you have n, the number of trials is finite and fixed. You know the number of trials and they are fixed. The trials are dependent. No, they are independent, right? Multiple independent. In a binomial distribution, these trials are multiple but independent. And outcome of random experiments, that is results in dichotomous classification of events. So dichotomous is basically two types of events, that it can be success or failure, it can be, so two types of outcomes, right? So it will result in only two, there will be two results, right? Binomial dichotomous classification of events. And P, the probability of success is constant for each trial. Yes, so the success and failure, so they have equal possibilities. For every trials, there's going to be two results, and every result, probability of success is constant for each trial, probability of failure is constant for each trial, right? So from the options, we can say that option 2 is the right answer, because binomial distribution cannot be used in the dependent trials. It is for the multiple independent trials, right? So binomial distribution you use in case of multiple independent trials. Then comes question number 5. The moderately large number of items chosen at random from a large group are almost sure on an average to possess the characteristics of the larger group. Which principle of sampling is this logic based on? So we have principles of sampling. In statistics we have various principles. So these principles, which is about that large number of items if chosen at random from a large group, are almost sure on an average to possess the characteristics of the larger group. If you have a sample you have selected from this larger group, then it is the on an average it is going to be almost going to be sure that this sample will represent the characteristics of this entire large group. So this is the principle of statistics regularity, right? However, principle of inertia of large number is basically that if you increase the sample size, if you have this sample size in case number 1, then you go for a larger sample size, all other things remain constant, this this sample will be more accurate, right? This sample will be more accurate. The sampling errors can be reduced if you go for a larger sample. So this is principle of inertia of large number about. And principle of statistical regularity is simple, that if you are choosing a sample from a large number of population, you are choosing a sample, then this sample will possess the characteristics of the larger group. So this is principle of statistical regularity in the question. And principle of inertia of large number is, if you go for a larger sample you will reduce many sampling errors, that sample will be more accurate. Sixth question, arrange the steps of research in the sequence in which they are presented in the thesis. So in the thesis you will first go for problem, statement of problem, then you go for review of literature, then you present the conceptual framework, basically the variables and the relationships between various variables. So conceptual framework you present, then you present your results and discussions. So this option number 3 is the right answer for the question. Moving on to the seventh question, match correctly the items of column 1 with the items of column 2. Ontology, ontology and epistemology. So ontology is basically um, when you study the being, whatever in nature, whatever is there. So all about that. It is about being, right? Everything realistic, everything about nature. Epistemology is about the knowledge, study of knowledge. Then methodology and method are the tools, and methodology is the overall analysis of these tools, these, right? So we have to match them. So we can see that there's survey. So survey is a method, we know, right? So option D matches with option 3, right? Then comes the ideographic. So ideographic is a methodology, right? Ideography is a methodology. We have a methodology, we call it ideography, and one is nomothetic, right? So ideography is basically that there's always gonna be, it is almost used in sociology. Most of the time it is used in the sociology, that for every current situation there gonna be different reality, right? That it is basically about when you study various communities, various different groups. So the reality for one group is reality for that group only. For any other group there's gonna be any other reality. So that is ideography about. There's a term called nomothetic, which is another methodology, another approach for research, which says that you can generalize things, right? So in this case you cannot generalizing. So these are two different approaches we use while we study something. So a study which says that for every community there's going to be different situation, for every result is confined to a specific situation, it cannot be generalized. That is ideographic about. And nomothetic is that you can generalize. So nomothetic you can use in sciences, and ideographic you can use in the social sciences, behaviors, right? So you can match methodology with ideographic because it is an approach. Methodology is basically an approach how you are going to solve the problem, and method is the tool you will use while solving the problem. So we have found two matches for C and D. Moving on to A and B. So we learned that ontology is about being real, about the nature, about however it is, right? So it is realism. And epistemology is about the positivism, that you are trying to, it is based on basically three sets: that belief, truth, and justification. You have some truth, you have some belief, you have some justification. So it is basically the study of the knowledge. So you can relate it with the positivism, that you can create knowledge. So it is how knowledge has created. Epistemology is all about that. So the right answer for the question is option number 3, that ontology is about realism, being, what is being. Epistemology is about positivism, that we can create knowledge. It is about truth, belief, and justification of that. Methodology is about the method, the approach while solving the problem, and ideographic is one of them. Method is the tool which is used in study in solving the problem, and it is survey, one of them. Tool is survey, you can conduct a survey and gather the information. So we are done with the question number 7. Moving on to the next. In social sciences, a central issue is the question of whether the social world can be studied using the methods of natural sciences. This statement refers to the issue of, so it is about the knowledge, right? So we, in the previous question we studied that epistemology is about the knowledge, how the knowledge has been created, right? How knowledge has come. So in social sciences, a central issue is the question of whether the social world can be studied using the method of natural sciences. So it is about the question how to generate the knowledge, how to create the knowledge. It is about that. So it is of course about the epistemology. Ontology, we learned that it is about being, it is about what is present, what is there. Axiology, however, is about the it is about ethics, right? The religion, ethics. And etymology, it is about the origin of various words, right? The origin of words, when you study how this word has come, from where it has come, its history. So that is etymology. Axiology is about the, about your ethics, your values. When you study ethics, values, all those. And ontology is simply the nature, the being, the realism, and epistemology is the knowledge system, how the knowledge has been created, the justification of that truth, the beliefs, right? So this statement is about epistemology. Answer 3 is the right answer. Moving on to the next, inductive argument proceed from, we have two types of arguments, deductive and inductive. So deductive is simply uh, we have two types of arguments. Inductive is from particular to universal, right? Like you can take an example of Newton. From inductive you can take an example of Newton, that he studied that apple is falling, then he studied, then he looked various other things are falling, everything is falling. From single events he generalized that there's a gravitational pull, everything falls down, right? So that's, you are moving from particular to universal, that not only apple fall, everything fall, it is universal, it is applicable everywhere. So that is inductive about. However, deductive is when you deduct a from a theory, you deduct, right? If there's something which is universal, and from this universal you can deduct something, that if everything falls, apple falls, so it is opposite, right? So inductive is about particular to universal. When Newton saw that apple falls, right, leaves fall, ball falls, everything is falling, that means he is moving from particular to universal, right? One result to which is applicable everywhere. However, deductive is when you have a theory, right? There's a gravitation force, and from this theory you deduct something, that this will fall because this is a, there's a gravitation force. So that is your deductive, you are deducting from the theory. And inductive is from the various events you are creating a uh, universal theory, right? And the last question is, if the average of five numbers is minus 20, 20, minus 20, 20, right? You have x1, x2, x3, x4, x5, and their average. We know the formula for average is that sum of the numbers and total number of numbers, right? So you have five numbers and their sum divided by 5 is minus 20, right? Now sum of three numbers is 32. Sum of three numbers is 32 plus sum of two numbers, right? Sum of two numbers divided by 5 is equal to minus 20. So you can just shift the 5 here and it will become minus 100, right? Minus 100 it will become, and this side you have 32. Sum of three numbers is given 32 plus sum of two numbers you don't know. So sum of 32, this is, this side it's plus, this side it will go and it will become minus. So it will become minus 132, right? So this is sum of two numbers is minus 132. Now what is the average of two numbers? Because they are two in number, formula for average is sum divided by total numbers. So this becomes 2 6 minus 66 divided by 2, 2 6 are 12, 1 and again 6. So option A is the right answer for the question. For the uh, three numbers, right, the average of other two numbers is, right? So you were left with two numbers, their sum, and you conducted the arithmetical operations and you found that minus 66 is the average of the remaining two numbers. So that's it for today. I hope you liked it. Thank you. Have a great day.